so we're at class 21 here. Inverse functions, day 2. So we're going to continue. We talked about inverse functions last class. We're going to continue that discussion. I just handed out take-home quiz 4. It's due next class, where we will also be reviewing for test 2, which is Friday. Also today, project 2 is due. So if you haven't already handed it in, put it in your folder. Okay. So let's go through these preview exercises together. Okay, so I've given you a relation, and remember a relation is just any set of ordered pairs. So I've given you 4 ordered pairs there, which is makes a relation. So what's the domain of this relation? -2. Ooh, why? What is wrong with writing -2 to 2? Anybody? No, they're part of the domain because they are points in the relation. Yep. This notation, -2 to 2, means every single number between -2 and 2. Like it includes -2.76342, right? So I don't want to include every single number. It's just the x values for those 4 points. Okay, so my domain is just the list of the 4 x values for this relation. Okay. And then what's my range for this relation? Okay, when I list things in sets, we typically don't repeat them. So I'm just going to put in a 1 and a 4. So I have 4 inputs, 2 outputs. So those are my domain and my range. All right, if I want to reverse the components of each ordered pair and write the resulting inverse relation, so that first point, -2, 4, becomes 4, -2. Second point was -1, 1. Switch the x and the y, and I get 1, -1. 1, 1, when you switch in the x and the y, it stays the same. And 2, 4, switch the x and the y, and we get 4, 2. So what is the domain of this function? 1 and 4. Yeah. Those are the 2 input values, the only 2 x values for that relation. And what is the range? Yeah. Okay. Is it surprising that my domain and range for the original relation and the inverse relation swapped? No, it's not. It's not surprising because that's what inverse relations do. They swap x and y. Domain is the set of all x's and the range is the set of all y's. So of course they're going to switch. All right. Is the inverse relation, that's this guy, is the inverse relation a function? Why not? It doesn't pass the vertical line test if you plot those points. Yeah, because I would have a 4, 2, and a 4, -2 on the same vertical line. So this is a no. Sorry, this should be a 2. Thank you. There we go. Thanks. That's okay. I appreciate it. Okay, so is the inverse relation a function? No. Fails vertical line test. You have to sort of imagine yourself plotting those points and seeing you have 2 points that have the same x value but different y values. So it fails the vertical line test. Now, a function whose inverse is also a function is called one-to-one. So is our original relation a one-to-one function? No, because its inverse is not also a function. So this is no. Okay, so let's look at some formulas rather than just a list of points. So does every function have an inverse function, and how can we tell? So to answer this question, I'm going to look at two different functions. I've got x plus 1 and x minus 1 squared. So if I look at f of x equals x plus 1, I just listed 4 random points on that graph. Okay. So if I put in x is -2, I get -1 for y. If I put in -1 for x, I get 0 for y. So just like in my head, I made a little xy chart and I listed some points on that graph. If I reverse the components, so if I swap my x's and y's, -2, -1 becomes -1, -2. -1, 0 becomes 0, -1, etc. Okay. Okay, so for the function f of x equals x plus 1, different inputs always produce different outputs. Okay, so that means that the inverse of f is a function, right? So this guy is a function, and this guy is a function, right? The original is a function, we already knew that. But when you reverse the components, I don't ever have an x comma y where I have different x's related to the same y. Okay, so this one is a function, right? Okay, so x plus 1 has an inverse function. Let's look at x minus 1 squared. So again, I picked 4 random points on the graph. When I put a -2 in there, -2 minus 1 is -3, and square it and you get 9. Right, so I got these 4 points, reverse their coordinates, okay, and then look at the result. Is that list of points representative of a function? No. What is the problem? The vertical line test with this point and this point, right? They're going to be on the same vertical line. 4, -1, and 4, 3 will be on the same vertical line at x equals 4. So this is not a function, right? So the inverse of x minus 1 squared is not a function, okay? Because certain inputs from the original produce the same output. So g is the inverse of g is not a function. So when we swapped the inputs and outputs for functions f and g, we noted that the inverse of the linear function x plus 1 is a function, but the inverse of the quadratic x minus 1 squared is not a function. So let's look at a graph for the function and tell if it has an inverse. So I want to draw a horizontal line at y equals 4. So that is this horizontal line here. Okay. How many times does that line cross the graph of f? F is the straight line. Once. Yep, crosses it once. One time. How many times does that orange horizontal line cross the graph of G? Twice. Yeah, right here and right here. Okay, so that leads us to another line test, right? We have the vertical line test for a function, right? And then we have the horizontal line test, right? And that says if any horizontal line, like the one we just drew, y equals 4, intersects a graph at 2 or more points, then the graph of the function will not have an inverse function. Right, so for f, it only crossed once, so that means it did have an inverse function. For g, it crossed twice, does not have an inverse function. The horizontal line test tells you whether the inverse is a function. Yeah, the original vertical line test tells you whether the graph itself is a function. And then you do horizontal to tell if its inverse is also a function. Yep. Yep. That will eliminate a lot very quickly. Yeah. All right, let's look at how to find the inverse of a function algebraically. If a function is defined by an equation, we can obtain the equation for f inverse just by interchanging the role of x and y in the equation and solving for y. So your textbook refers to this procedure as the switch and solve strategy. Switch x and y and then solve for y. Okay, so let's list the steps for finding the inverse function of a function and we'll do it. Okay, so my first function I'm going to find the inverse of is f of x equals 5x minus 6. Verify that the function's one-to-one. Usually you do this by looking at a graph or knowing what its graph looks like. You just sort of need to know its general shape. 5x minus 6, what does that look like? It's just a line. Yep. It's got a y-intercept of -6 and a steep slope. Something like that. Does that graph pass the horizontal line test? Yes. So this passes HLT. Okay, so the reason we do that first is because now we know it's worth trying to find the inverse because we know it has one. Okay, it passes HLT, we know it has an inverse function. Okay, step 2 is replace the f of x with a y. So this is going to be y equals 5x minus 6. Step 3, interchange the x and the y. So make all the x's y's and all the y's x's. Then you solve for the y. So what am I going to do first if I'm solving for y here? Add 6 and then divide by 5, right? So I'm going to get y equals x plus 6 over 5. Okay. And that is actually my f inverse of x. Once I've finished solving, that's it. That's f inverse of x. That's how you find it. And then we should verify that it's an inverse by verifying that we get a round trip. That if we run the function machines f and f inverse back to back, you always get a round trip. You get x back. So we'll just do it one way, one order to make sure that it works. Okay, so I'm going to put, we'll just do it with a number first. What happens if I put a 2 into the function f? The original function f, 5x minus 6. You get 4. 5 times 2 is 10, minus 6 is 4. Now I want to take that 4 and dump it into the f inverse machine. What am I hoping to get out? If I did everything right, what should I get out? 2. Okay. So if I put a 4 into my f inverse formula, 4 plus 6 is 10 over 5 is 2, right? So that's good evidence that I did it right. I just picked a totally random x. Yep. Yeah, you pick a random x, and then the thing you're looking for is that whatever you put in should come back out. All right, so that's it for my demo. You can start your class activities.